You know, when you look out into the vast, empty universe, there's pretty much just lifeless darkness. But as far as we know, there's one exception: us, Earth. So what is it? What makes our planet so incredibly special? Well, to figure that out, we're going to have to travel way back in time. We're going on an epic journey to see how our world was born and find out why we're even here to ask the question.
The thing is, the answers are buried deep, deep in our planet's past. Our story, it's just this wild, spectacular chain of random events. It's a mix of total catastrophe and sheer coincidence. It's kind of crazy. But every single disaster was actually a crucial step on the path that leads directly to us, right here, right now. It's a story of fire, ice, creation, destruction, and a whole lot of luck.
All right, let's dive in. Our journey kicks off almost 5 billion years ago. And trust me, our planet's starting point, it wasn't a home. It was more like hell. This first chapter is all about fire, massive cosmic collisions.
Okay, so picture this. It's 4.54 billion years ago. This is the early Earth, and it's a boiling ball of liquid rock. We're talking surface temperatures over 1,200 degrees Celsius. There is absolutely no air to breathe, just this choking mix of carbon dioxide and nitrogen. And forget solid ground. There's nothing but an endless, churning ocean of lava. And believe
Coming in hot is a young planet named Theia. It's about the size of Mars, and it's hurtling towards us at 20 times the speed of a bullet. It's on a direct collision course. The impact? It's just staggering. The blast wave rips around the entire globe, completely liquefying both planets and just blasting trillions. So for about 1,000 years, gravity starts to do its thing with that massive cloud of rubble. And it pulls it all together, forming a ball over 3,000 kilometers wide. And that is our moon. But here's the kicker. Back then, the moon was way, way closer to Earth. Its gravity was so powerful that it made our young planet spin like crazy.
Okay, so we've got a planet and a moon, but we need another key ingredient. And it arrives during a 20 million year long assault from space. Yeah, for 20 million years, meteors left over from the solar system's birth just rained down on us. And tucked inside these meteors were tiny little crystals with droplets of water. This bombardment, it was relentless, but it's what gave us our oceans. Think about this. Every single drop of water you drink today is billions of years old, and it traveled.
So now we have a world with water and land, but it is still completely hostile and totally lifeless. The next part of our story is all about how Earth took its very first breath, all thanks to some of the tiniest organisms you can imagine.
So, down in the shallow oceans, these weird-looking mountains of living bacteria start to appear. They're called stromatolites, and what they did was, well, it was basically magic. They used photosynthesis to soak up the power of sunlight, turning carbon dioxide and water into food for themselves. But the real game changer was what they released as waste: oxygen. These tiny, humble bacteria slowly started to fill the oceans and the atmosphere with the one gas that all
But just when things were getting good, Earth's progress took a terrifying nosedive. Intense geological activity creates these huge new continents of rock. Now, volcanoes are pumping CO2 into the air, which makes acid rain, and all that new rock on the surface just soaks it up. With all that CO2 basically being scrubbed from the atmosphere, the planet's thermostat just plummets. This kicks off a runaway ice age that encases the entire planet in ice 3 kilometers thick.
For 15 million years, Earth was just a giant frozen ball. So what saved it? Volcanoes. They finally broke through the ice and started pumping the atmosphere full of CO2 again. But this time, since the rocks were covered in ice, there was nothing to absorb the CO2. The greenhouse effect kicks back in, big time, and the whole planet starts to melt. It's a perfect example of how catastrophe can create a new opportunity. Because as the ice melted, it released huge amounts of oxygen that had been created by a weird chemical reaction with the sun's UV rays. This great thaw basically...
All right, so coming out of that deep freeze, we've got a world that is just supercharged with oxygen. Life, which had been barely hanging on, now explodes in the oceans. And from there, it begins its long...
Welcome to what we call the Cambrian explosion. In these new, oxygen-rich oceans, life just got bigger, weirder, and way more complex. You've got these bizarre creatures like armored slugs called Wiwaxia. You've got trilobites, which are ancient relatives of insects. You even have huge predators, like the 60-centimeter-long Anomalocaris. But maybe the most important creature of all is this little guy, Pikaia. It's only a few centimeters long, but it has what might be the very first spine.
So, the oceans are absolutely teeming with life, but the land? It's completely empty and incredibly deadly. Why? Because it's just getting blasted by the sun's lethal radiation. The solution, amazingly, came from the air itself. Way up in the atmosphere, all that oxygen we talked about started reacting with solar radiation, and it formed a new gas, ozone. This created a protective shield, like planetary sunscreen, all around the Earth. It absorbed the deadly rays, and finally,
At first, it was just simple stuff, like mosses. But the real game changer for plant life was the evolution of the seed. See, unlike spores that had to stay close to water, a seed was like a little survival pod. It carried its own food and its own water supply. This tiny, tough little package meant that plants could finally leave the coasts and spread deep into the continents. And that's what truly transformed.
So, life has now conquered the land, and it's leading to an age of giants. But, as we've seen again and again, our planet is a pretty restless place. That cycle of life and death was about to happen on a planetary scale. It was going to wipe the slate almost clean, and, in doing so, create an...
Now, before the dinosaurs, the world belonged to a whole different set of giants. The air was so thick with oxygen that insects got huge. I'm talking dragonflies the size of eagles and millipedes that were 2 meters long. You had massive reptiles like the tank-like Scutosaurus munching on plants, and they were hunted by these just perfectly engineered...
And then, it all came crashing down. The single greatest disaster life has ever faced. Huge volcanic eruptions in what is now Siberia just pumped the atmosphere full of gas. This created acid rain and triggered runaway global warming. The oceans literally turned toxic. We call this event the Great Dying, and it wiped out 95% of all species on Earth. It's the closest. But out of the ashes of that extinction, a new group of reptiles rose up to rule the planet, and they ruled for an incredible 165 million years. Of course, I'm talking about the dinosaurs. They seemed absolutely invincible, but their reign was ended in a single catastrophic instant. An asteroid, bigger than Mount Everest, slammed into the Gulf of Mexico. It triggered a global firestorm and plunged the world into darkness for years. But their end was our beginning. Small mammals who'd been hiding in the shadows of the dinosaurs, they managed to survive, and they inherited...
So the end of the dinosaurs, that really marks the beginning of our story. In this last chapter, we're going to see how a very specific chain of events, both geological and climatic, on a planet now ruled by mammals, paved the way for a brand new kind of creature, us.
Okay, check out this chain reaction. 47 million years ago, the Earth's plates are still moving around. The Indian plate slams into the Asian plate, and over millions of years, this colossal slow-motion crash buckles the crust and pushes up the Himalayas, the highest mountain range on Earth. Now, this massive mountain range acts like a wall, blocking moisture coming in from the ocean. This totally changes the climate in East Africa, turning lush rainforests into dry savanna. This forces our primate ancestors to come down from the trees and learn to walk on 2 feet to find food and survive. Isn't that wild? The creation of a mountain range on one continent literally kick-started human evolution on another.
This really puts our entire existence into perspective. Imagine squeezing all of Earth's 4.5 billion-year history into a single 24-hour day. On that clock, the dinosaurs wouldn't get wiped out until late in the evening. And all of modern human history? Our cities, our art, our technology, everything.
So when you think about it, from a ball of fire to a snowball, to a water world, and finally to a green paradise, our planet's journey has been one of constant, violent, and incredibly creative change. We are the result of every single collision break along the way. But you know what? The Earth is going to be around for at least another 4.5 billion years. Its story is only halfway through. So the real question is, what will our chapter